Let us continue to study relations, functions, and graphs. And in this video, we want to look at graphs of linear functions. Now, the general form of a linear function is y equal to mx plus c. And this function will produce a straight line graph. X and y are variables. That means x and y vary. As you go along the graph, they keep varying, they keep changing. M and C are constants. They don't change, they are constant. They are numbers that do not change throughout the graph. Look at a few examples. For example, suppose you say you have y equals 3x plus 7. This is one example of a linear function. If c equals 0, you would have y equal a number, an example like 2x, y is equal to 2x. That will give you a straight line as well. Alright? Now, we won't look at a graph just yet that has m equal to 0. We'll do that in another video. But we can actually look at a graph in which c equals 0. Because if m equals 0, there would be no x there, and we want to keep the x there for now. Now, suppose we start with a simple one. Simple example. Let's say we have y equals, in this case m is 1, x, and c is 0. So here m equals 1, c equals 0. We can see that 1 times x plus 0 is just 1 times x. But then you don't necessarily have to write the 1 here. You just write y equals x, y equals x. Now, what we want to do is fill out the table that we have here with the relevant values. Alright? Now, in this table, we're going to have x values and y values. We will put in x first and get out y. Let me use a value of x as x equal -5. And let's use 0 and 6. -5, 0 and 6. Now, we use 3 points here. The thing is, though, to draw a straight line, only 2 points you need. And you draw the straight line through the 2 points. But it's good practice to use 3 points in a graph to just make sure that the line goes through all 3. So that you can know that you did not make a mistake once the line goes through all 3. If it doesn't, seem to be off course and doesn't go through all 3 points, then you have to check your working because you made a mistake. Now, y is equal to x. We have x values and we want y values. Let me increase the size of my number so you can see them more clearly. X and y. When y is equal to x and x is 1. No, x is -5. What am I saying 1? X is -5. What is y? Y equals -5. You can see that because y is x, so whatever value x takes, y takes the same value. So we have -5 here. When x is 0, y is, remember y and x are the same, y is equal to x, So when x is 0, y is also 0. When x is 6, y is also 6. So we have that graph. Now, what we say about this graph is that we have 3 points and it is the graph of y equals x. Let's go to our whiteboard. We have -5, 0, and 6 for x. We have -5, 0, and 6 for y. We have a graph paper here. -5, 0, and 6. From 0 to -5 and then 0 to 6 is close to the same distance, right? What we want to do is line up our graph paper so that all the numbers will hold on the graph paper, and also that we make efficient use of the graph paper. Now, if we put our x-axis down here, the horizontal line that represents our x-axis, let's do that. Suppose we put it here for argument's sake, and we line up our numbers from -5, -4. I'm just checking to see if I can use 2 centimeters for each unit. -5, -4, -3, -2, -1, 0, 1, 2, 3. How far did it go? 6, 4. We see that 2 centimeters equal 1 unit is too wide scale. Let's use 1 centimeter equal 1 unit for now. So if we put back our x-axis here and I write -5, -4, remember I'm putting it on each of the thick lines, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. You notice we could very well have put it further to the right. You see that? So we could have started, if you move 0, if you have -5 here, then you would have 4, -3, -2, -1, 0. We could have put this 0 here and have 1, 2, 3, 4, 5, 6. So you could have also put -5 here. But let it stay like this for now. The thing is, when we're going to plot our y, let's see what happened. Y goes down to -5. Now, if we start at 0 and we put our y-axis and we are going down to -5, let's say we use the same scale, guess what would happen? We say -1, -2, and there's no space for -3. And -5 would fall off the graph way down. So you have to be careful exactly where you put your x and y axes, right? So axis AXES, because in some books and websites you have one AXIS, more than one AXES, plural, right? Now we want to line up our x and y axes. So we know that the x-axis will be close to the center. The y-axis, since it goes from 0 to down to -5 and from 0 up to 6, will also be close to the center. So we can put our x-axis close to the center. Let's say here. Can safely guess that it would work there. And our y-axis as well. So we will work with this for now. our x and y axes. Now, let's say we have our 0 at the origin, -1, -2, -3, -4, we went to -5. We can also add the -6, -7 in case we want to draw a graph even a bit larger than the scale is, right? But we are going to the right hand side of the x-axis now. Remember, this is x-axis. 1, 2, 3, 4, 5, 6. Let's say 7. We put an additional one here. But you don't necessarily have to do this, right? You don't necessarily have to put on additional numbers because you are looking at a graph ending at -5 and +6. If you do have the space, you can add the numbers. Now, let's look at the y-axis. The y-axis has numbers going as far down as -5 and as far up as 6. So we have -1, -2, -3, -4, -5. Nice. 1, 2, 3, 4, 5, 6. So you see that. Now we want to plot our points. We have when x is equal to -5, y is also equal to -5. So -5, -5. So we identify -5 on the x-axis, go down to -5 on the y-axis. The point we plot should be below -5 for x and beside -5 for y. So I use my x and plot this point. Then the next number, 0, 0. I put 0 there because 0 is nice to work with it. You know that any number multiplied by 0 gives you 0. So it makes calculation a bit easier. So 0, 0 is really at the origin. So we plot this as our second point. And then 6, 6. We go to the first 6 is for the x and the next 6 is for the y axis. So right up here is going to be our next point. Now we draw a line through these 3 points. Let me make my line a bit thicker. Draw our line through these 3 points. Nice. Now, let's set up the information that we want for our graph. We say the title is the graph of y equals x. The scale on the x-axis, 1 cm equals 1 unit, and the y-axis, 1 cm equals 1 unit. Good. So this is the graph, and we label the graph. I label it down here instead of within this region, because most graphs will have readings within this region, and you traditionally put the numbers on for the y-axis on the left. This is the y-axis, you put these on the left, and the numbers on the x-axis below to leave this area clear. All right. Now this is y equals x. So that's our graph. Now let's put another graph there. we can just erase these. I want another graph. Suppose let me get a larger eraser and erase these. Suppose instead of y equal x, I put the graph of y equals 2x. What would it look like? Alright, I have that graph to draw. Y equals 2x. I'm going to use the same -5, 0, and 6. No, I could use that, but I would have to draw a bigger graph. So I'm not going to use the exact values of -5, 0, and 6, since each number will be multiplied by 2. Let me use -2, 0, and 3 for x. Now, when x is -2, what is y? When x equals -2, y equals 2 times -2, which is -4. So I have -4 here as that answer. -4. What happens when x equals 0? When x equals 0, y equals 2 times 0, which is 0. So when x equals 0, y is equal to 0. Then what happens when x equals 3? When x is equal to 3, y is equal to 2 times x, 2 times 3, which is 6. So I see that when x is 3, y is 6. So let's plot these points. -2, -4. At -2, -4, I look at the x-axis to find where x is -2. Then I go horizontally to go beside y is -4, and I identify this point. All right? Identify this point. Now the next point is 0, 0. I remember that. 0, 0. It's right here. And then the other point, what was it again? 3, 6. X is 3, y is 6. So we have x equals 3. We identify 3. Y is 6. We move up so that we land right beside the 6. So what we have is this other point. Now, let's draw our line through these points. Straight line. Alright, so we have a straight line here through these points. And we see that this is the line y equals 2x. Now, the one that says 2x is steeper than the one that says y equals x. Now, what does the 1 and the 2 simplify? Because there is really a 1 there before the x for this. What do they signify? Let's see something. What happens with the 2x? Suppose we look at this line and form a right angled triangle. Right? So the line for y equals 2x have 2 points on the line. I want to form a triangle and 2 points on the line. We have here as one side and here as the other side. This is a triangle. Now, how tall is this triangle? How many units? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units high. So this triangle, the height of it goes 10 up. Now, how wide is the triangle? 1, 2, 3, 4, 5. 5 wide. So this triangle is 5 across. We have y equals 2x. Suppose we divide the 10 by 5 and say 10 divided by 5 equals 2. 10 divided by 5, 2. Let's look at the other line. Suppose we have 2 points. We choose 2 points and we form a right angle triangle. Let's say we choose this point and we go down to here and we go across. So we choose 2 points on the line. We have one line vertical and the other line horizontal to form our right angled triangle. Let me change the color of that to match the line. We go down here and down here, across here. Now, this triangle is how high? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 high. So, the triangle that I formed on y equals x goes 11 up. Let me write high. 11 high. How wide is it? Start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is 11 wide. If we divide the height by the width, we get 11 divided by 11, which is 1. And you notice there's a 1x here. Now, you could try the same thing with y equals 3x and see if the height of the triangle divided by the width of the triangle that you form between any 2 points on that line will give you 3. Well, I know that it will be 3. It will give you 3. If you try it with y equals 3x, draw the line, choose for the graph, choose 2 points on the line, form a triangle, and divide the height of that triangle by the width. Now, how steep the line is depends on the number that multiplies x. You notice the 2x is steeper than the 1x. Y is equal to 2x is steeper than the 1x, right? In fact, the steepness of a hill or a line is referred to as the gradient. The gradient of the line. So basically, in the general form, y is equal to mx plus c. The number that multiplies the x, the m, is called the gradient. And the gradient determines the steepness of the line. How steep the line is. If the line is a hillside, how steep the hillside is. The steeper it is, the harder to climb up. Alright? So, what we're going to do is just end this video now and we continue with this topic in a different video.